Fireworks. These fleeting spectacles of light and sound have captivated humanity for centuries. They are a testament to our ingenuity, a fusion of art and science. From the initial spark to the final burst, fireworks embody the laws of physics and chemistry. Each display is a carefully choreographed dance of elements, a symphony of color and sound. For a brief moment we gaze up in awe, as the night sky transforms into a canvas of vibrant hues. Fireworks remind us of the beauty that can arise from seemingly simple ingredients. They embody our primal fascination with fire and our desire to shape the world around us. But how did these dazzling displays originate, and what is the science behind their magic? Our journey takes us back through time, to the ancient land where fireworks first ignited the imaginations of our ancestors. The story of fireworks begins in China, over 1,000 years ago. Legend has it that a cook accidentally stumbled upon the recipe for gunpowder, a mixture of sulfur, charcoal, and potassium nitrate. This potent concoction, initially used for religious ceremonies and to ward off evil spirits, soon found its way into pyrotechnics. Early fireworks were likely simple bamboo shoots filled with gunpowder. When ignited, they would explode with a loud bang, creating a spectacle of light and sound. These early displays quickly gained popularity, evolving from rudimentary explosions to more elaborate presentations. The Chinese art of firework making spread throughout the world, carried along ancient trade routes. From the Far East to the Middle East, and eventually to Europe, fireworks illuminated the night skies in celebration of festivals, victories, and coronations. At their core, fireworks are meticulously engineered devices designed to create specific visual and auditory effects. The key ingredient is gunpowder, providing the explosive force that propels the firework into the air and ignites the colorful stars within. These stars, the heart of the fireworks visual display, are small pellets containing a mixture of fuel, an oxidizer, a binder, and color-producing chemicals. The fuel, often a type of sugar or starch, provides energy for the reaction. The oxidizer, typically potassium perchlorate or potassium nitrate, supplies the oxygen needed for combustion. The binder, often a type of dextrin or resin, holds the star's components together. Finally, metal-containing salts create the dazzling array of colors that paint the night sky. Each element, when heated, emits light at specific wavelengths, resulting in the vibrant hues we associate with fireworks. Painting the night sky. The science behind colors and patterns. The stunning array of colors seen in fireworks displays is a testament to the power of chemistry. Metals, when heated to high temperatures, emit light of specific wavelengths, which our eyes perceive as different colors. By carefully selecting the metal-containing salts incorporated into the firework stars, pyrotechnicians can orchestrate breathtaking displays of color. Strontium salts, for instance, produce brilliant reds, while barium compounds create vibrant greens. Copper compounds yield blues, and sodium salts produce bright yellows. To achieve purple hues, a combination of strontium and copper compounds is used. The arrangement of stars within the firework shell determines the burst patterns we see in the sky. By carefully placing stars in specific configurations, pyrotechnicians can create a wide variety of effects, from simple bursts to intricate shapes and patterns. The explosive science. Understanding the anatomy of a firework. The magic of a firework unfolds in a carefully orchestrated sequence of events. It begins with the ignition of a lift charge at the base of the firework shell. This charge propels the shell high into the air, leaving behind a trail of smoke and sparks. Once the firework reaches its desired altitude, a time delay fuse ignites a bursting charge located in the center of the shell. This explosion ignites the firework stars, propelling them outward in a dazzling burst of light and color. The sound of a firework is produced by the rapid expansion of gases caused by the explosion. The intensity of the sound, or the boom, is determined by the amount of gunpowder used in the bursting charge and the altitude at which the firework explodes. Larger charges and higher altitudes result in louder, more resonant booms.